Here we have a question 2 that says the structure below shows a system that is in a state of equilibrium. The strings with the forces T1, T2, and T3 are joined at point O. The weight of the block suspended from T3 is 2000 newtons. Now, your main point here is O. So O is going to experience all three forces. Let's just start off by drawing the forces that it experiences. So we know that we're dealing with T1, T2, and T3. Here, T1 goes to the left, so it is acting horizontally. T2 acts at an angle of 70 degrees. And T3, which basically represents the weight of this object, the weight is given as 2000. So I will leave the name as T3. Normally we would write it as FG, but here they've already allocated a name to it, T3, so that's fine. Just want to fill in this value that is 2000 newtons. Now 2.1 says, what is the difference between a scalar and a vector quantity? So this is something that you actually learned in grade 10. You know that a scalar has magnitude only. So it's a physical quantity that has magnitude only. And a vector is a physical quantity that has magnitude and direction. 2.2 says, what is the resultant force acting on the block? And give a reason. Now they've mentioned something important here. The system is in a state of equilibrium. So we know that the resultant force acting on the block is going to be 0. And the reason is that the system is in a state of equilibrium. 2.3 says, draw a labeled closed vector diagram of forces showing all the forces acting at point O. Indicate two angles in your diagram. Now remember that closed vector diagrams are drawn using the head to tail method. So I'm going to start off here with, it's up to you which force you want to start off with. Let's just work in order. I'll start off with T1. So I've got T1 going to the left. So where the arrowhead of T1 is, the tail of the next force needs to start. The next one I'm going to work with is T2. So T2 is going at that angle. Here we're going to have T2. And lastly, we have T3, which is going straight down. So notice that the tail of T3 needs to touch the arrowhead of T2. And the arrowhead of T3 needs to touch the tail of T1. So this is our closed vector diagram. And we need to show at least or indicate two angles in our diagram. Now this creates a right angle triangle, so you can include the 90. They would give you a mark for that, right? But the other angles that you can include is what you actually have here. So if you look at this, from Euclidean geometry, we know that this Z or N shape forms alternate angles. And what we know is that alternate angles are equal. So that is also 70 degrees, which means that on our diagram, this angle is 70 degrees. And I mean, I know they asked for 2, but we can calculate the remaining angle here at the top. So we know that angles in a triangle add up to 180. If we minus 90 and minus 70, we know that this is 20 degrees. But I'm just going to leave it like this since they asked for 2 angles only. Now 2.4 says, determine by means of calculation the magnitude of the forces T1, T2, and T3. So the thing here is that we already know what T3 is. T3 was actually given to us. So we can just state that, right? T3 is 2000 newtons. And that is acting downwards, but since they asked for magnitude, we don't need to give direction here. But we know in our calculations, we would use it as a negative value. Now going up to the diagram, I just want to start off by breaking up T2 into components since that is acting at an angle. So for components of T2, we would have T2y acting up and T2x acting to the right. And the angle that we're using here is 70 degrees. Now we need to work in both directions. We need to work horizontally using F net x, and we also need to work vertically using F net y. I'm going to start off by working in the y direction. So we'll have F net y is equal to 0, because remember the system is in equilibrium. It is stationary, so there is no acceleration. Now acting up, you're going to have T2y, and acting down, you're going to have T3. So let's start off with that. Okay, here we have it. F net in the y direction is equal to 0. T2y positive since it's going up. Negative T3 since it's going down. Now let's further expand. We know that the y component has sine, so it's going to be T2 sine theta. And I mean, you can take this T3 over to the right since it was negative on the left. And let's substitute. So we know the angle we're working with for T2 is 70. We know that T3 is 2000. Now it's positive on the right hand side. To get T2 alone, we are going to divide both sides by sine 70. This is what we have. Let's calculate. So I get T2 as 2128.36 newtons. So far we know what T3 and T2 is. Now we're just left to get T1. Going back to our diagram, T1 is acting horizontally. So to calculate T1, we're now going to work in the horizontal direction. So in the x direction, we're going to get F net x is equal to 0. When we expand, we have T1 to the left, so that would now be negative. And we have T2x to the right. Okay, let's write that down. Okay, here's what we've got. And I'm actually going to take, you can do this right now or you can do it later on. I'm actually going to take this T1 over to the right just to make it positive. And for T2x, I'm going to expand as T2 cos theta. Now, we already calculated what T2 is, so that is 2128.36. That's going to be cos 70 degrees. All of that is equal to T1. Let's calculate. So I get T1 as 727.94 newtons. So there we have it. We have solved for T1, T2, and T3 was actually given to us. So that is it. Please remember to like, subscribe, and turn on your notifications for more content.